Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, everyone, we'll get started. Thank you very much for coming along to this afternoon's talk. I'd like to introduce you to Dr. Daniel Angus from the University of Queensland in Brisbane, Australia. He is a lecturer in the School of Electrical Engineering and Information Technology.
Oh yeah,
Information
Technology, Electrical Engineering.
And the School of Journalism and Communication, and he is a member of the new Centre for Excellence in the Dynamics of Language, a $28 million federally funded centre in Australia, about to do some absolutely amazing things to do with computational methodologies and various forms of language and a lot of health stuff as well. He's been working on this amazing piece of software called Discursis for about 6 years now, partnering with a range of academics from various aspects of the communication and other disciplines, psychology and health and speech pathology and others, and trying to find ways of doing various sorts of visual text analytics. It's really interesting new kinds of technology, and I hope that you enjoy this talk. All right, Dan, over to you.
Thank you very much, Sean. So I'm going to try and keep this fairly brief and do kind of the 10,000-foot view of everything that we've done with this technology in the last little while. But please break in and ask questions as I go if you like, or otherwise save them to the end, and hopefully we've got some time for some interaction. So as Sean explained, the Discursis program has been, I guess, my baby for about 6.5 years now, but it couldn't be possible without also the work and by my colleagues Andrew Smith and Professor Janet Wiles. Janet was the director of the Thinking Systems project, which funded this particular piece of research for many years, and now she's also one of the thread leaders on this new Centre of Excellence. So we've got 7 years of funding to do more awesome research in this area of linguistics, and hopefully you see some very good things coming out of that in the next little while. So Discursis is motivated by one thing, and that is the idea of information visualization. And visualization is a really powerful tool that we can use to help not just explore and understand our own data, but also communicate our findings and our analysis and interpretation to others. And so we really kind of took this idea of this twofold kind of purpose of visualization and used it to motivate the design of our Discursis tool. So the idea that it's a tool for analysts to analyze their own communication data, but then it's also a useful tool to help those analysts communicate their findings to external audiences as well. So it really serves those two purposes. So today's talk, I'm going to briefly introduce you to another similar technology called LexA Mentor. LexA Mentor was developed by my collaborator Andrew Smith, and he developed this many years before we started work on Discursis. And LexA Mentor is a technology that underpins a lot of what Discursis does in the conceptual modelling and natural language processing realm. Then I'll introduce you to Discursis, and I'll take you through some examples of Discursis and how we've applied it to a variety of communication data sets. And then I'll take you briefly at the end through some work that we've been doing in taking it from the visual back to the metric space, so how we quantify some of the visual patterns that we're seeing with the actual tool. So let me start at the visualization method. Now, before I get started too much into this, I want to just briefly introduce you to what we mean by concept. So I'm going to use this word concept. I may also use theme during the presentation. And I want everyone to, I guess, be on board with what I mean by that. So what we have here is there is a set of words, these what we call evidence terms. In this case, we've got bark, cat, breed, pet, and dog. Now, these words can occur in some text or speech. And our model that we're creating here, this conceptual model, is the idea that the concept dog can be invoked by any one of these particular evidence terms once you reach a particular threshold of evidence. And the idea that these words here are all related and the thickness of the lines I've drawn there give you a sense of how much that particular term provides evidence for the presence of a concept dog. So the idea that within a text, if we see some of these terms, it might imply that the concept dog is present in that particular section of speech, or it might be a tweet, or it might be a status update or a forum post. But any of this text that we're interested in analysing, we're looking for these evidence terms to invoke this concept dog. You can have evidence terms that invoke different concepts. So the idea, these are not exclusive relationships. Bark, in this case, can invoke the concept tree as much as it can invoke the concept dog. With these particular models, we create this from the data itself. So given a corpus of data, of text data, we build the concept map from the text itself and try and use a Bayesian statistical approach to model, well, what are the actual salient concepts and what are the evidence terms that make up these particular concepts. One of the things to note here is that, I mean, in this particular artificial case I've given you here of this concept of dog, it's not always that we get a concept name that may make sense to us as an analyst immediately, and so we allow our actual interpreters to rename these concepts how they like. So a good example of this, if I was to say, well, here are the evidence terms: Venus, Mars, Saturn, Jupiter. What concept does that bring in people's minds? Planets, solar system, right? But what's going to happen with the particular statistical model we've got here is you're going to find that the highest weighted evidence term, that might be Venus, is going to name the concept. So the concept might be called Venus, but in actual fact, when you look at the evidence, the bag of words with it, it makes more sense to think about it as planets. So you have to interpret these concepts to make sense of them a little bit. Right? And that's just the nature of the technique we use to do the modelling. So this particular approach is used by LexA Mentor, which is a commercial software tool developed at the University of Queensland. And LexA Mentor came out, and its purpose was to give it a text and for it to discover what are the main topics within that text. So the idea of profiling and surveying almost a physical landscape of concepts. Right? So the idea that if you've got a text and you're interested in, well, what are the major salient concepts within that text, LexA Mentor is a tool to help you do that. And not just what's in there, but how do these things actually relate to each other? So how do concepts organise spatially, and how do you actually determine how these things relate? And you can also do things such as if you put a conversational transcript in there, you can actually find out, based on the speech utterances of the participants in that data, who's talking about what. So we've got a doctor-patient conversation transcript here, and this is a visualization from the LexA Mentor program. So within this is a doctor and a patient. The patient's name is David in this case. Of course, that's not the patient's real name. But what we see here is that they're discussing a variety of concepts, and the concepts that we've taken from the data are all these black words here. These are the name tags, so this tells us where those particular conversational participants situate within the conceptual space. And the proximity implies relatedness. So it uses a force-directed layout to lay out the concepts in that space, and it also adds these theme circles. So these try and do a higher level aggregation of concept groups. Yeah.
Is your basic concept clustering model like LDA?
No, it's different to LDA. So LDA doesn't tend to give names and these kinds of rich descriptors like you'd get in LexA Mentor. LexA Mentor is far more driven. I mean, and as I said, it's more of a Bayes inspired statistical processing algorithm. Also, LexA Mentor does different pre-processing than what LDA does. So often with LDA, the pre-processing you use to determine the topical breakdowns is quite specific. But you could, I guess in one way you could consider it LDA-like, in a way that you're still, with LDA, you're building the idea of evidence kind of terms to a particular topic slice within your data set. The other thing here is that with LexA Mentor, it recognizes that language such as this aligns to power law distributions with frequency of particular terms and such. And so what it tries to do is it tries to come up with a set of concepts which sit within a particular area of that power law distribution. So rather than you say, I want 10 topics from this, it would suggest, well, within this corpus you've provided, there seem to be 50 emergent concepts dropping out naturally from the data. So you don't actually tell LexA Mentor how many concepts you want. It kind of bubbles up from the statistics of the language itself, what it suggests are. Now, unfortunately, LexA Mentor's concept engine is proprietary. So, and I don't even know the full details of it because I'm not an employee of LexA Mentor. So there are some particular tweaks within there, but I do know it is a Bayesian-inspired algorithm, and it does particular pre-processing on it to give this particular list of concepts. But the important point here with LexA Mentor is that what we're seeing is that the doctor here is in close proximity to things such as David, protective, spray, home. These are the concepts that the doctor is talking about. And when you drill into the text underlying this, and this is the good thing about the tool, is it allows you to inspect every one of these concepts and see it in context. So you can see, well, what is the text that's actually supporting this particular concept? And so what you see there then is that protective and spray, this is talking about paints and protective clothing. Right? And this patient in this particular case has gone in complaining about dizziness. And so because the doctor is kind of picking up on these particular concepts here and mentioning them a lot, it would seem the doctor understands what's actually causing and suggesting that it might be paint and the lack of protective equipment that might be the cause of the dizziness that David is presenting with. And this is actually what was the root cause of this particular problem. What we don't get here, though, is a sense of the temporal dynamics of the interaction. So what you get is you get the topics and the concepts that are being discussed by the two parties in the conversation, but you don't get a sense of the ordering of where they appeared in the conversation itself. So that's where we came in with Discursis. And so we're fortunate enough to get this particular grant called Thinking Systems, which gave us some room to be able to kind of push into this space a little bit to see, well, hang on, can we actually extend the LexA Mentor model to do more of this kind of temporal processing and temporal unpacking of the communication? So we're interested in this, and as an analyst, if you've been given some kind of conversational data, a forum transcript, some kind of social media feed, what you might want to do is see the global structure. So from end to end, now it might be an hour's worth of conversation, or it might be a day's worth of Twitter data. What's the kind of 10,000 foot view of the entire data set as a whole? Are there critical time points within that? Is there a point within, say, a negotiation within a business meeting where a critical thing happens that then means the deal is broken, or it's something else has happened? And can you divide the conversation into sections to then break your analysis into the various components and these kinds of periods of the conversation that might naturally kind of drop out? So that's where we came in with Discursis. So what we do is we take a conversational transcript, and it's simply just formatted as a comma-separated value file. You just have each line with text on it, and you can add other information such as the speaker's name and onset length if you've got it, and these kinds of pieces of data. So we place it down the diagonal, and this will become apparent in a sec why we do this. So what we also do is we size the squares located sequentially down this diagonal according to the amount of text in each of those. Now, as I said, you can use real timing information if you have access to it, but otherwise it uses a heuristic, which is simply the number of words to size the squares. And in this case, we've coloured the doctor in blue and the patient in red. So this is the patient's, one of the patient's initial turns, talking about having dizzy spells and such for many years, and these kinds of things. Now what we do is underneath this is we colour this in according to conceptual overlaps between the turns in the speech. So this is the real kind of heart of discursus, is that what we've done is we've taken each turn and we've looked at the terms that are occurring within that and used them as evidence terms for the presence or non-presence of particular concepts. So once you've coded every turn in the conversation according to what concepts are there, then you can do pairwise comparisons across the entire data set to work out where are there co-occurrences where these particular speakers are repeating the same concepts. And it's interesting that if you do this and you do the full pairwise comparison through this, now naturally this is a symmetric comparison we're doing, so we only have to show one half of the diagonal. But what you begin to see is there's structure. And there's this interesting structure that's emerging from the actual conversation here. And when you actually start drilling into some of the features of this structure, some things start to pop out. So one of the things I'll draw you to before I get talking too much about the structure here is that there was a finding from Beckman and Frankel in 1984 about doctor-patient consultations. And they said, and they suggested that these consultations where the doctor allows the patient to elaborate early in a consultation on their concerns and do so for more than 18 seconds tend to lead to statistically better outcomes. Right? So diagnoses and also the patient's understanding the concerns of what's going on. Interestingly, some recent data suggests that in America at least, most of these early parts of a doctor-patient consultation are less than 10 and sometimes 5 seconds in length. Right? Now, one of the interesting things with the visualization is you get to see this very quickly. Right? Who's kind of having those turns early. But not just that. What you're actually seeing in this square here is that there is conceptual consistency amongst those first few turns. Right? So we can actually look at that and it suggests that, well, even though the doctor is kind of interjecting between those turns, that group of turns taken as a collection seem to be on the same topic, right, or set of concepts. So we see kinds of features in these. So we call these engagement blocks. This is where you're getting these multiple speakers all repeating each other in the short term, and you get these blocks attached to the diagonal, which suggests there's a short-term structure here where people are repeating each other close in time. And we can actually look vertically to see, all right, so if these initial turns here are setting the agenda of the consultation, and if this is where the patient is talking about what their problem is, what you might like to see in this particular context is that those things are actually referred to through the remainder of the consultation. It's no good a patient going to a doctor and saying, oh, look, I've got all this dizziness and I'm really concerned. I'm wondering what the dizziness is caused from. And then the doctor going on to talk about cancer or something, right? That's maybe not related to dizziness or something else, and move the consultation away from what was the primary concern. So you can see this by this echoing down here in the recurrence plot. And so all of these blocks of colour suggest that the associated turns down the diagonal are actually repeating those concepts that were mentioned early on. Now, interestingly, if you go below this engagement block that I pointed out earlier, you notice that what we actually have is a lack of recurrence. You've got this white space. And when you drill into the consultation transcript, you actually see why this is the case. Because this engagement block here is where they're talking about David and how much David is drinking and whether he's using recreational drugs. And it turns out that David's not really doing this much. And so, yes, you get a lot of this conversation around concepts of drinking and drug use, but they're not necessarily related to the dizziness, or the doctor decides at that point in the consultation, no, this is not going to lead us to the diagnosis. This is not the root cause of the problem. And so then doesn't talk about them anymore. And you see this because that white space suggests that this remaining part of the consultation doesn't make reference to drinking or drugs. And then at the end, we see this quite interesting structure, which is this horizontal stripe, which we called, in this particular context, summary stripes. And this is where the doctor's offering some kind of diagnosis and summarising the consultation that's happened to that point. Now, we looked at a lot of these consultations in the system, and we found that a lot of these visual patterns were present in good consultations where not just that the doctor had arrived at a diagnosis, but that the patient actually showed signs that they understood what that diagnosis was. So it's not just enough that the doctor knows in their own head and through their own speech that they've arrived at a diagnosis. You need the patient to understand what is wrong with them as well. Right? So we found these particular patterns in those kinds of consultations. The last thing I'll show you as far as visual features that we have in Discursus, we also allow and put in this thematic overview down the diagonal. And so this gives you a very, very quick way of summarizing, like I was saying, that 10,000-foot view of the conversation, what's kind of happening thematically through the consultation in time. So if we actually we take a good example on the left-hand side and we take a poor example on the right-hand side, have a look and visually inspect and see what you think is different about the two of those particular cases. And as I said, these are only two cases I'm showing you here, but these were patterns that were very much apparent within the entire corpus of consultations we looked at. So on the right, you might see that, well, where is the patient? Right? Remember I was talking about that first 18 seconds being incredibly important. Well, it seems that that first 18 seconds or so is taken up with mostly the doctor talking about things and the doctor repeating themselves but not repeating the patient. And then later on, we see very little summarization of the consultation. Right? We see some of this engagement here. This is mostly around, once again, this kind of checklist style interaction where the doctor's asking about drinking and drug use. Right? This happens again in this particular consultation. Yeah.
Surely the measure of those two examples is interior to the conversational acts themselves. And what you've done is you obscured the interiority of those conversational acts and evoked the visual patterning as a criteria to judge success. So in the right case, how could I possibly know whether your claims were right? I would need to know what the specifics of that particular interior organisation of talk about a particular instance, about, the person on the right who's a patient might be interacting with that doctor subsequent to a whole range of different regimes, such that they don't need to say much, right? How can you possibly make a judgment where you take out the evidence and render it thus, and then pretend that's the evidence?
So these particular consultations were assessed under a range of regimes. So the conversation, so when I say assessed as good and poor, that is not me taking the visual and saying, oh, because these particular
patterns. Us to believe you, but there's no evidence in that except a visual cue which you're asking us to take on credit. But the evidence for the merit of that credit is in the talk, and you're not showing the talk.
I'll show you the example in a sec if you like. But I want to get clear first the idea that there are particular visual metaphors that present within particular cases. And this is the thing, we did the systematic study of this. This is the paper's in Plots 1, if you want to read the details of this and how we went about it. The idea that these were assessed under the communication accommodation theory regime, and that looks at things such as discourse management. It looks at a whole range of behaviours accommodation. So the idea of accommodation, particularly in a health context, is that the physician needs to listen to what the patient is saying and repeat back to them some of those concepts in some way. Now, when that happens, it is possible that it happens in a way that discursus wouldn't pick up because they modify their speech in a way that, yes, at some broader and taking background context into account, they might say and use particular evidence terms that means, yes, you don't get the recurrence appearing. But in looking at so many of these as we did in this case, they did these consultations that had been assessed as fitting into these bands of good discourse management, good accommodation, good patient outcomes, good, adherence to treatment by the patient, and actually asking the patients themselves to rate the effectiveness of the consultation itself, right? And the patients feeling as though their concerns had been met and that it was good talk and that all these things had been met. That was the visual pattern that was apparent for those, right? And for those where the patients felt their concerns had not been met, where we saw a lack of good discourse management, right? They fit into that right-hand visual pattern. Now, I agree. There are cases where you can get particular visual patterns where it could mean both, say, good discourse management and poor discourse management, right? Depending on the kind of speech. These are a particular conversation constructed in a very particular way. These are all first presentation consultations as well. So this is the first time the doctor has spoken with a patient. I definitely do this very differently for second and third, and say you with your family doctor that you've seen for 30 years, and you might not need to say a lot to know, and there might be other cues there other than speech that you're picking up on to sense that there is alignment going on or such. But as a first step, just taking the text, it was apparent to us, particularly in this case and in other cases, which I'll show you in a second, that there are at least interesting features there and features worthy of further exploration, right? When I get to it in further work, we're looking now at picking up things such as prosody, right? So looking at audio cues, right? And how do we actually model audio cues such as prosody, such as, say, F0 and other particular features of the audio, which can get us some of that richer context you're talking about and pick up some of those micro cues. So the way in which you might use sarcasm would modify the meaning, and so semantics alone won't give you that. But if I press on, I might show you some examples where this is a bit more apparent. So in this conversation here, this is one when we showed it to our colleague Bernadette Watson, she's a psychologist at UQ, and she collected a lot of these particular cases. I showed her the visual, and she'd done over 100 of these particular recordings with many, many different doctors. And this kind of answers your point to a degree. I showed her this consultation, and she told me exactly who that doctor was when she looked at that. As soon as she saw that visual, she said, "Dan, I bet you I know who that is." And she told me, yes, this is this particular doctor. Because that doctor, she'd nicknamed the doctor the lecturer, right? And they were very repetitious. Their behaviour was that they would repeat themselves a lot and lecture their patients. And what you see here is this kind of back channeling of by the patient, and the doctor being highly conceptually consistent, repeating the same thing again and again and again. Right? So that behaviour manifests in that particular way. So let's just look now at some other examples of other conversations we've looked at. These are dementia conversations, so those with aged care residents who have some kind of form of dementia. And we've been working very closely with our colleagues in the Centre for Clinical Research to examine this data. And what's coming out of this are guidelines for how we might actually go about training care providers to provide and try and get meaningful conversation from people with dementia. Dementia is one of these terrible conditions where it affects centrally a lot of the language production, and what we see with that is that affects social bonding. Right? So it's difficult for families then to come to terms with that because they lose the ability to converse and to bond through conversation with those family members. So this kind of research is critically important in ways in which we can try and encourage better conversations, more meaningful conversations. So we put this data into Discursus again, and what we found was there were these particular features in a lot of these conversations, with these people with dementia and with care providers that had done some of this particular training. And what we're seeing is that this is actually really good conversation with people with dementia. The idea that normally there is not a lot of conversation, you don't get a lot of speech from the person with dementia, but in these cases, in these little sequences, we're finding that the person with dementia was giving these discussions around their childhood and other kind of aspects of their life, and this is one of these weird things with dementia, is that how it affects memory. And so you find that long-term memory is something which can be picked up on more readily than short-term memory. Right? And so they lose some of that short-term memory and that ability. Yeah?
So all those triangles you've highlighted are blue, which just means that it could be the care provider staying on the same topic for a while.
And that's exactly it. So it's the care provider staying on the same topic. And this is what we're finding in this, was that when the care providers persisted on a topic for a time, they actually then were able to get, in some of those instances, meaningful interaction. So they actually got some speech from the person with dementia. Now, there were some topics, though, where the care providers persisted, and it's not in this example here, but in some of the other data we looked at, where the same thing was happening, but then they wouldn't elicit the end response from the person with dementia. And when we examined the kinds of topics that they were talking about and persisting on, it was those that were personally relevant to the person with dementia that they would eventually get a response for more often than those which are, say, about the weather or about the local football team on the weekend that did well or about the local shops or something like that. These more short-term, less kind of personally relevant, these topics that they're persisting on, the care providers persisting on, are tapping into these more kind of long-term meaningful memories. Right? We liken this as a metaphor to walking through a rose garden. Right? And the idea, if you're walking through a rose garden and you're nimble and able-bodied, you kind of run to the rose bush and you look at it and smell and go, oh wow, come on, have a look at this is fantastic. And by the time that person, who's less able-bodied than you has caught up, you're already running over here to the next bush and going, oh, and this one over here is great. And so the same way with this conversation, what we're saying to the care providers now through this research is slow down. Right? So those normal kind of conversational rules about if you don't get illicit responses. So in a normal conversation, if I bring up a topic and someone doesn't really feed back that topic or show interest in it, you move to another topic because that's how conversation's formed. But in these, you can't do that, right? You need to give those people time to catch up so that they can actually begin to respond. Now, look, it's a lot more subtle and nuanced than that, but we've got a couple of papers in this area now, if anyone's interested in accessing those and to learn more about these kind of clinical skills training that's going on now through UQ. Another good case of this that we looked at, this is some data we got from collaborators at UCSD, and this is with autism case studies, and these are matched pairs with autistic children and typically developing children. And what we see in these is that there were a couple of cases, or most of the cases with those with ASD, you would get two kinds of behaviours, almost like a bimodal distribution, where you would get very little interaction between the adult interlocutor and the child with autism. So they're put into a room and the adult is told, just have a conversation with this child. They're not told whether the child has autism or they're typically developing. The data does suggest that the adult picks up very quickly, though, which kind of camp they fit into. But in any case, what we see is we see two behaviours, not a lot of topical kind of convergence or exchange, and then all of a sudden, if you pick a topic that or the child moves to a topic that they're interested in talking about, in this case it was video games, that's it. They just repeat that for the remainder of the conversation, right? They fixate on that topic and keep repeating it again and again and again. Whereas in a lot of the typically developing cases, we find more of this kind of mutual exchange and movement around the conceptual space. So there's not this fixation on, say, one set of concepts. So as I said, that's the visual, and taking the visual is one thing. Now, within that, in those particular contexts, and this is the really important thing, and when I start talking about metrics, I always put a caveat here that you don't want to look at metrics in isolation, and particularly not with these rich social interactions. You need to always examine the data underneath it before you start moving into this metric space. But in any case, I've shown that there are some particular visual features which occur within particular data sets. And for these, we're interested in ways in which we can actually begin to do things like data mining and other kind of processing on it to maybe pick out some of this structure. So this is, and the approach that I'm using here is what we know as a recurrence plot. Right? So ours is rotated, so we can align the text in it in the software, which I'll show you in a minute. But traditionally, recurrence plots run with the origin in the left-hand side up the page. Now what we see here is two particular systems. This is a weather index, a weather pattern index, the Southern Oscillation Index, which is very important in Australia. And this is a human ECG recording. And what you see is there's particular dynamical structure in both of these time series. Right? Now, those are very different systems to conversation, but they're examples of the way in which physicists and other scientists have applied recurrence plotting. And these same people came up with a set of rules around how to actually measure some of those structures. So things such as entropy, determinism, laminarity, trapping time, these kinds of measures which can begin to pull out some of those visual features and come up with numbers to describe the dynamics of the system. So with ours, it was a bit different, because the difference here is that these particular systems are unary, right? So there is one measure here that they're measuring and they're recurring in time. But we have interacting parties. So we need different metrics to be able to do that. And so that's exactly what we did. We came up with our own set of metrics inspired by these same systems, but to describe this social interaction patterns around concepts and how concepts are being deployed. So here's an example of a broadcast interview. This is from Australia. It was a program called Enough Rope by Andrew Denton. And Andrew Denton would interview each week some kind of famous person or otherwise ordinary person from the street. And in these particular cases, so this one is Professor Brian Cox, who I'm sure you all know. It's the physicist, and he works at CERN. And on the right-hand side, we have a conversation with Renee Rivkin, who was convicted of insider trading in Australia and did jail time for that particular crime. And these particular conversations are known within the media discourse analysis schools as an expert interview here, and an accountability interview, because of the nature of the social identity of the guest. All right, so in this particular case, and when we actually looked, we looked at about 100 of these conversations across these different kinds of categories. And we found that within the experts, they did this kind of thing where you see a lot of self-repetition and these big turns, right, by the experts. So Andrew Denton, as the interviewer, is allowing them to explain their theories and thoughts and just gently steering them through, often on the same topic, to try and move the conversation along. It's a very kind of this interesting exchange. Now, that's very different to the kinds of patterning we see here with someone who is a convicted criminal, who is sometimes more evasive, and shows very, very different behaviours. Now, in doing this, we can begin to count some of these patterns to begin to see how these things fall out at some metric level. And in doing that, across our 100 conversations, we got these kinds of distributions. So what we found was the accountability interviews mostly sat in this bottom quadrant here, where it's Denton repeating his own concepts a lot. So if we go back to the visual here, these kinds of patterns here, where Denton's having to ask repeat questions again and again and again, but very, very little of the guest repeating their own content, right? So by evading the question in different ways, they won't be repeating their own concepts. Whereas you look at experts, and experts tend to situate in this particular upper quadrant, where they're very good at repeating their own concepts over and over again, right? And establishing a narrative and going around that. Right? Now, interestingly, we don't get, and celebrities are an interesting case that fall across a wide array. Right? And I mean, celebrity as a category is fairly broad as well. You can have, a celebrity can be everything from, say, a sports personality through to an actor, through to a celebrity chef. So this is quite a broad category. But this is still going on, this particular research. But it's interesting how, at least for experts and accountability, we're getting some clear, at least at this preliminary stage, differences between their behaviours at a metric level. Now, these are not just for dyads. I've shown you up until now mostly these two-party conversations. I'll just finish up by showing you an example of some new work that we're preparing at the moment, where we're looking at broadcast interview television programs. So these ones, this particular one in Australia that I'll show you is called SBS Insight. So SBS is the network and Insight is the name of the program. And it's very much set up very similar to what we have here. So you have a host where I'm standing, and then you have an audience in this kind of configuration where you have a mixture of experts and lay people. The experts, the producers actually contact ahead of time and bring them in for the show specially and fly them into the city where this is filmed. And lay people, they pull them off the street, they find them through other ways to fill up the rest of the auditorium and give it this kind of amphitheatre, this big kind of live television feel. Now, what's interesting in this, and it's been studied by other scholars, is the idea of what is the purpose of the layperson in that particular context. And there's a lot of talk that the layperson is marginalised and that their talk doesn't really matter, or that their talk is only there to try and make it look like, well, there are these experts, but they're connecting with the real person on the street. Right? We're not all just these academics and such that don't connect with the common man, that this is a bridge to get through to that. Now, in analysing these particular discourses with Discursus, we found with this metric analysis that we're getting these kinds of configurations. Now, this is just done in Gephi, and what we've done is we've measured the degree of conceptual similarity in the speech patterns of our guests on the program. The ones in red are the experts, and this was around, it was a program around emergency rooms, hospital emergency rooms. So you had a lot of doctors and hospital administrators, and they tend to repeat each other's speech a lot. The thickness of the line indicates the degree of conceptual overlap. These lay people that do get to speak tend to be on the outer, right? So thin lines connecting them. Now, there is one exception here, and that is this person, Susan Candlish. Now, the exception being there, she was the one who, at the start of the program, they often show a pre-recorded video of someone's personal story. And Susan Candlish was the one whose story was told very early on. It was her son who had acute appendicitis, and it actually ruptured before it could be taken out because she got sent to the wrong hospital and waited for 10 hours or something in an adult hospital, and they couldn't operate on a child. Right, so this story was told early, and as a result, it was an agenda-setting device that was then picked up on by a lot of these doctors later on. They would refer to it as, and in that case that we heard before, right? But it's interesting because there were plenty of other cases presented by these other lay people here, but they weren't picked up on with the same valence that that first story was. So as I said, this is still research in preparation at the moment, but at the moment it's fairly interesting findings how we can actually begin to show and visualize what is only yet being talked about in journals and such in text. We've never actually seen this kind of interaction play out in a visual form such as this.
How are these nodes arranged on?
So that's a force-directed layout. So I used Gephi, and I just used the OpenORD algorithm within that, which is like a spring-based stress layout. So the clustering is meaningful in this sense. So their actual position relative to each other does imply a strength of connection. But it's an incredibly highly dimensional space. So there is still a lot of stress within these networks because you can see there is a lot of connections there. So I'm going to show you just a quick demo of the program itself. There's more details on the website as well that you can go and check out for yourself, and all the publications are linked to up on the website as well. So let me just flick across to the program. So this is it running. Now, I've got a whole set of projects already loaded. It's fairly quick to run a project. It's only a few seconds to actually build the conceptual model and get it running. So we give a variety of interaction within this. As I said, the text underneath it is the really important thing, and so this is what we've tried to keep fairly present with the interaction with the particular tool. So when you hover over one of these particular utterances within this speech that we've loaded, you get a view of, well, who is it, the number of the utterance, and the concepts that have been tagged to it. You can click on that, and straight away you get the actual underlying text from that particular turn. Now, if you're interested not just in a single turn, but you're interested in how two turns connect, you can click off the diagonal, and then you see that's utterance 5 and utterance 8. They connect around the concept trying, and you can see why that's the case, because utterance 5 is saying, I'm just trying to give a metaphor here to get us kicked along. Right? That invokes the concept trying. And
is that always the case that the concepts are tagged absolutely? It's not a probability that.
It is a probability, but we invoke a threshold. So we say that it has to get above a certain threshold to be invoked, but beyond that, then yes, it's a weighting.
So you're not showing the probability in the UI?
No, we're not showing the probabilities. Yeah, so it's we could reveal it. How meaningful it would be for an analyst just kind of going through a whole text like this, I'm not sure, but you can get it with a data export. So yeah, you can get it other ways. But then if you're interested in a section of text, you can actually select a whole section, and then you see these sections of speech. And this shows you why we've rotated the discursus plot away from the traditional recurrence plot, is so we can actually do this kind of staircasing effect with the transcript lined up with the actual recurrence plot itself. And these are the metrics I was talking about below. So we have given them names. These names are defined in the papers that we point to on the website, what they actually mean. So when we say something like engagement, it's not necessarily theoretically grounded engagement that someone may use in, say, social psychology. It's a summation of recurrence elements, if you want to get super technical, but it seems to make sense that it points to some form of engagement in that sense. Yeah.
Does it really have to be a conversation?
No.
Sort of, if you look at a lecture,
Yeah.
right, there's structure in a lecture, and thematically there are topics which you come back to. Have you considered sort of taking sort of these longer lectures, be it university lectures, be it public lectures, and sort of understanding, is there a thematic progression? Is this sort of a
take TED
confusing
talks or
random collection of observations?
So we've done analyses of things like theses. So my students have put their theses into the program and looked at them, because with something like that, or an academic paper, for instance, you might be interested in the structure. So the introduction points to results that are to come, and the conclusion should then tie. So you imagine maybe a good, like a conversation or a lecture even, should tie back to the original kind of stated aims at the end. And so you might see this long range recurrence elements at the end where it all ties it back to the beginning. So you're absolutely right. You don't have to actually have an interaction for this to be useful. You can do monologues. You could do another area where people are interested is putting, say, play transcripts and such in there. So, jam Shakespeare in there and see what that looks like, and whether there's a particular semantic structure to the way that ideas and concepts are developed in time within those particular pieces of drama or literature. So yeah, absolutely. It just needs to have some kind of temporal structure that you're interested in trying to get the heart at, is how the semantics are developed within that. And that's the real key here as well. It's about the semantics. So we're not capturing in the system things such as eye gaze. We're not capturing physical gesturing yet. We're not doing prosody. We're not doing these things. We've just started and worked to try and get the conceptual level right as best as we can. And now we're looking, and particularly with this new grant that we've been fortunate to get, we're beginning to look at the audio aspects of this.
Audio, you mean like the tension in the voices? Or
Yeah, you could. We're thinking things such as stress and pitch and intensity, and there's a whole host of qualities that you could extract potentially from the audio signal. But then therein lies the danger, right? Because there's a lot of features, and you need to make sure you select the ones which are meaningful, and you're not just then creating patterns which don't actually infer some kind of grounded understanding of what is actually going on. So just because people are aligning in pitch, does that necessarily mean that they're engaged? So there needs to be some theoretical grounding around that.
You do. I'm not sure what you mean by theoretical grounding, except how you might offer a contentious reinterpretation of the practices. So I wonder if many years ago, Emmanuel Shegloff wrote a great riposte to speech act theory. And it seems to me what you're offering here is kind of a version of speech act theory. And the speech act theorist's response to Shegloff's analysis, which shows that you could determine pertinent meaning only through an analysis of the sequential organisation of meaning. So what a prior term came to mean was manifest only in the subsequent terms, and was a key lacuna in speech act theory which doesn't allow for that. And the speech act theorists was to say, well, we're not too worried about particular evidence, we're interested in creating a theoretical edifice. And then the question then is, well, what's the purpose of the theoretical edifice if it's not helping you focus on the evidence? And Shegloff said, I'm dismayed, because surely if you're interested in conversation, for example, you'll be interested in what's actually done in the conversation, not in the production of a theory which leads you away from the mechanics, the features, the nature, the practices, the social organisational features that lead conversation to have the order that they have. What we have instead in speech act theory is the theory about speech acts as being some kind of Kantian objects. Well, likewise here we have a kind of vision of communication as being some kind of Kantian visual apparatus. And one's led to believe almost that the visual apparatus is a better measure of conversation, worse possible even that the visual could be used to tame and offer strictures for conversation. And the possibility is that, for example, doctors should be told to abide by a rule of 18 seconds, or even worse, that doctors should bear in mind in their conversation an 18-second rule. Now, if they abided by that last rule, that rule must only be accountable and sensible and plausible in the theory if it's manifest in their orientations. But I don't see how your model allows that manifestation to be made visible. Your model takes you away from the evidence in such a fashion that you lose sight of the evidence.
I respectfully disagree about it taking away from the evidence, because the evidence is still here, right? As much as you can, right? We're working with a transcript, right? This is what has been taken away from that particular conversation. Right? Now, if you're fortunate, you might have an audio recording and a video recording as well. But say the only evidence we have of the interaction is the text transcript itself. The program itself allows you to go back to that at any point in time that you like. And that's one of the important aspects of this, is it doesn't, we try to not to move you too far away from the data itself. Now, the way in which you interpret the visual features that are present within that is what I mean about the theory that you want to bring to bear on that. So if you're interested in the degree to which, and your particular theoretical perspective says something about discourse management, right? And you're interested in the amount to which people say the same things, right? Then this might be a tool that can inform that and allow you to examine the data with that kind of in mind, to look at examples where that is going on, right? But as you say, you know, if your particular perspective on how you judge a conversation as, you know, and how you want to examine a conversation doesn't involve, you know, if your perspective on what a conversation is doing is not one around, well, the concepts is what give it meaning, and what people are talking about is what gives it meaning at some other level, and it's about some other cue or some other kind of social construction of meaning or that, then probably this is not going to help you anyway. Because if you think that what people are saying is immaterial to some other level of connection that's going on, and the words, it doesn't matter what people say, like say, you know, married couples, when they talk, it's immaterial what they're saying, it's the way in which they're saying it, right? Then this is not going to help you. And I make no promise that this is the panacea in that sense.
Would it be fair to summarise this exchange by saying that you're taking these sort of patterns in the structure of conversation and you're adding a sort of a shallow semantics to help that, but the deep semantics of sort of truth, presupposition, relevance, consequential deduction cannot really be touched by these techniques. That's a whole other matter.
Oh, of course, absolutely, and that's a perfect summary. This is a first attempt, and I think this is the other thing that I think the solution, if there is such a solution to ever be had that gets at that rich semantics, it's going to take baby steps to get there, right? And I guess it's something I find frustrating within social science and some of the humanities, when people kind of look at these tools and balk and go, oh, there's no way you could possibly ever take the complexity of human communication and get it in here. Just look, you know, at how poor our tools are at obtaining sarcasm, or how bad they are at detecting, you know, this, you know, and as an example of that it could never be done. And I guess but the engineer in me says, well, no, this is one step in the way to a system which can begin to do this. And your points, I know you probably, they're provocative points to get us to that better system which can try and take some of that into account.
Sachs is saying if you look at talk, listen to talk, look at reading, read Rob Watson stuff on reading, you can see that there is an organisation to it which is visible, is oriented to, is manifest, is based on conspicuous features, and they can be all documented. Now, getting from that into to other sorts of questions you might want to be interested in is a difficult exercise, but there's a great deal on the organisation of talk, and my concern here is how distracting the tool is for you, and whether the price of the distraction is too great, it was nicely summarised here. But to say that there's not a great deal of understanding about conversational organisation is not right. There's massive amounts of it, right? But this is not telling me much about conversational structure as conversation is really organised. What it's doing is offering something different, which is I'm perplexed at what it's offering, because what it offers seems to distract me and distract one from looking at the salient matters of conversational organisation. Okay.
I guess my experience and with the data that we've looked at through the lens of this particular tool to date, and it has been done with people who are well versed in these particular conversational analysis and discourse analysis you talk about, is that they do find some value in it. At least the idea that, if you take an hour's worth of conversation and take the transcript of that, I mean, can you consume that in one glance, right? How many times do you need to listen through that to gain an understanding of it, like that, and then scale that again and again and again to end up with, say, hundreds of hours worth of conversational data to deal with. So the idea that,
this is a different thing, which might be interesting, but doesn't produce a better understanding of the conversation. To look at the visual tempo of a conversation that took an hour in a single image is an interesting thing. It's not telling me much about the conversation. It's telling me something about aesthetic re-renderings. And that can be fun, but I don't know what it's telling me. I don't know what it's telling me about the conversation itself.
Okay.
Can I ask a quick practical question?
Yeah.
So, suppose there was a conversation that never ended, like a chat room or a Facebook timeline. Is this robust? So, if I used your tool on the first 2 hours, and then used it again on the first 4 hours, in those two visualizations, would the first 2 hours look identical?
So, no, because when you build the conceptual model within this, it builds it off the data that you've provided it, so that's within the transcript itself.
The addition of data would change the conceptual model.
Would change the conceptual map because it's bottom up. Now, what you could do is you could fix the language model on one set of data and apply that to others. But therein lies some danger, because language is a dynamic construct that changes and meaning changes in time. So you have to be really careful. And this is this kind of where this, I think, maybe a middle ground needs to be found, is where top-down kind of ontologies need to meet these bottom-up. So, you look at all the ones who deal with grammar and such, and those who develop things like WordNet, that these, dog and cat are related, and everyone would agree that dog and cat are related because they're animals. But what about Bob and Fred, right? And what about these? So these other words which can take on different meanings depending on the very, and they can take on meaning within an instant, within a conversation, and then alter meaning again a few turns later. So that those dynamics, those temporal dynamics of how meaning is constructed through the way in which we converse, are very, very interesting things to study, and things that we're interested in looking at with tools like this, getting at in a bit more detail. So so for the moment, just for practical reasons, because as I said, you need to start somewhere, we build the concept model off the entire text, but we're currently researching ways in which you can actually dynamically construct this, so particularly with things like social media and Twitter and that, so you can actually adjust meaning in time and continually refresh that concept model.
I wouldn't in any way wish to encourage you to reveal any of the details of LexA Mentor. I'm not being an accountability interviewer myself. But I still lack an intuitive sense of what sort of thing it is and what it's actually doing.
So,
it clearly must have some inference rules for relatedness between words. It must clearly be able to identify words, list whether they're lexically ambiguous, more than one possible meaning, and consider all those meanings, and somehow put them together and form a cluster. And it's taking the relatedness of the words into account on the one hand, but also the time axis. There must be a sort of combining information, Bayesian.
Yep. So it uses a sliding window.
Time axis info and the semantic relatedness info, and producing a cluster and then saying, well, we seem to have a cluster here, and we seem to have another cluster here, but it may be overlapping a bit. Is that what it's doing?
Yeah, kind of. So what it does is it applies. So first off, it strips out stop words because they tend to appear with a regular frequency through most language. So yeah, and or and the, they're thrown away. So then you're left with what you're left with. Generally uses about a 2-sentence window, and it rolls over the text from end to end. And what it's doing is it's
surface structure grammar like spell check in Word has, for example.
No, it doesn't use any grammatical information. So what it does do. Yep. So it builds a table of co-occurrence and occurrence, and then through that it then applies a Bayesian-inspired set of algorithms to build a set of priors, and then infer from that those groups of terms that seem to kind of travel together through the text. They might suggest the presence of a singular concept, right? And that's where the real secret sauce is the idea of how you get from a group of words to a singular concept to kind of cluster them together. But it is, as you say, like think of it like clustering is a good way to do that. And then once you've done that, it's then about trying to figure out, well, how do then concepts relate to each other, right? And that's where it comes about the idea of where you get evidence terms that bridge between different concepts, their evidence that those concepts might relate in some way. And so after doing that over the entire corpus, you're then left with a set of concepts which have a set of weightings of evidence terms underneath them. Right? And it's through when we do the discursus approach then, in those turns, we're looking for the presence of particular words to invoke, and once you get enough of these evidence terms that are weighted high enough, that would trigger to say, yes, this concept is present here in this particular turn. Right? And then you would actually code each turn, and then you can do the pairwise. And we just use a cosine similarity score to compare the vectors within that sense.
Okay. I haven't kept up with psycholinguistics in recent years. Is there some sort of fundamental psycholinguistic work applying Bayes' theorem, Bayes' rule to relatedness between concepts and between words in text?
So you mean as in experimental work where on people?
Some clever person has put this into a proprietary algorithm, but is there some fundamental work about the phenomena and how useful they are to rely upon?
Oh yeah, absolutely. Yeah, and I can point you to the research that points at that. Yeah, absolutely. So what's actually inspired this is inspired from some literature in cognitive science and such. So the idea that there is, it's always difficult when you say, oh, there's a human analogy, or it's like how the brain does it. That's such a complex system that you can't say that's how it does it. But certainly through some of that, it has inspired the development of these. So the nature of it is quite beautiful in my eyes because it doesn't try to assume that the system isn't complex. It embraces the complexity of the way that text organizes. And so the algorithms being used treat it as a power law distribution, as text is, right? Zipf's law says the way in which word frequencies work. And yet there's a lot of approaches within this field of natural language processing that assume that it's a linear relationship or such. And so that's a bit strange when you know that it's actually a power law distribution at its heart.
All right, well, we might end with the end of embracing complexity there. I really appreciate it. And thank you very much for the questions. A nice provocative speech, and obviously it did provoke some people, so that's good. So thank you very much indeed, Derek.
Thank you, guys. Thank you for having me.